I always feel like we need a drum roll.
We wouldn't happen to know any musicians, would we?
Indeed. Take it. Fantastic.
We on?
Mm.
Well, it's yes on my screen, so behave yourself now. No swearing. Good evening, everybody. I'll just wave a hand at you if you're all waiting. Alex is doing what Alex does.
Yeah, I am doing spacey things. Okay, there we go. And it appears we are live. Mark, how are you doing? And
I always feel like we need a drum roll.
Can I just say what a pleasure it is to have you back on Uplink 05 already? I mean,
yeah, it's very good. There's an echo on the line here. I'm not sure it's coming through you or through me, whether you've got the YouTube open. I'm not sure, but maybe me, of course.
No, it was definitely me.
Okay, good. Good.
It's the beauty of live streaming, just like live radio. You never know what might happen, particularly if I don't know what I'm doing. But
well, that's it's a good job. We're professionals, right?
Indeed. Well, don't spread it around. But so we're kind of moving forward with these uplinks at pace. But it's so nice not to just bring some wonderful guests to the table, but also to kind of mark some very special occasions. Of course, today is an incredibly special occasion, not just because it's celebrated annually, but because it's now been 50 years of Earth Day. So Mark, how did Earth Day come about, and what's its connection with space?
Well, I mean, you've actually stumped me there in how it started. You may know better. I mean, 50 years ago, so we're, just before the beginning of human spaceflight. I'm not quite sure. Was it whether it's linked to Stuart Brand and the whole Earth catalog thing? I'm not sure actually, but yeah. So I expose my ignorance on that one. But yeah, 50 years. And of course, in those 50 years, we've had human beings in space. We've had many satellites observing the Earth. And we're going to be talking to a couple of people today who are expert in that area, Earth observation, looking down instead of what I typically do is look the other way, away from Earth. And of course, one of the very important things is that over that period of 50 years has been this very long baseline, this sort of what we would call synoptic observations, the ability to keep going back to the same place with satellites as the technology improves, but always trying to maintain calibration so that you can compare, how has the Earth changed in 50 years? And I know you're not quite there yet, and I'm a little bit past the 50 years, but the Earth has changed very dramatically in that time. And I think, celebrating the 50th anniversary today at a particular time of crisis for other reasons in the world, I think will serves to re-emphasize that the coronavirus is not the only challenge we have to face. When we come out of this, we really have to think very hard about how we want our Earth to be preserved for humankind, or not. We can always make the choice not to preserve it, and then we'll be gone, and somebody else can have it. Maybe the chickens will come back, the revenge of the dinosaurs. Maybe they'll survive climate change.
Well, I'll be honest, my money is on the octopi. That feels like an inevitable one. As soon as they master fire underwater, I think it's game over. But maybe that's another episode of Uplink. But, I suppose it kind of connects with your Zoom background, with things like Earthrise, and the fact that when we went into space for the very first time, we were able to see the Earth not as a geopolitical map, which is what we all grow up with, but just as a single object set against the backdrop of space. And I guess we've talked in previous uplinks about the overview effect, just like what it does to people when they see the Earth. And it feels like that really figures in to so much of the ethics, the ideals behind Earth Day, which is saying that we are just a fragile vessel floating through space.
Yeah, and that actually does connect very closely, to Stuart Brand, who was the entrepreneur in California that started the whole Earth catalog as a kind of an alternative approach to how you would have a sustainable lifestyle in what, of course, was already a very capitalist society. Seen some of those he tells the story that he actually had a hallucinogenic trip one day in San Francisco, and he kind of felt himself hovering high up on a building and being able to see the curvature of the Earth, which he certainly couldn't, not from the altitude he was at. But it started him thinking about what it would be like to have images of the Earth from far enough away to see it as a globe. And he was actually responsible in part for getting those images taken and publicized. And he put them on the front cover of the whole Earth catalog. And then very soon afterwards, of course, Apollo 8 went to the moon and took that classic Earthrise picture as you go over the limb, like we have here in my background of the Earth, but with the moon and then the Earth rising above that. And those pictures have become iconic. Many of the astronauts have talked about that, and they talk about it even in low Earth orbit, which is where this picture is taken from. It's taken from the space station. So yeah, there's that ability to step outside a little bit and reflect, but not lose contact with the idea that somehow we can actually leave this and go away. You know, this is where nearly 8 billion people live. And when you see it from space and you see that tiny thin rim of atmosphere there, which contains everything, all life as we know it is, but you know, beneath that barrier, apart from a few astronauts on the ISS, you know, we need to contemplate how that ecosystem works: the clouds, the oceans, the rivers, the atmosphere itself, and underground as well, all of the reservoirs of carbon that are buried underground, some of which we're expecting for oil, but some of which will come out on their own if we don't turn the temperature down. So there's an enormous amount in this complex ecosystem of the Earth that we've learned. We've also a lot to learn still, and you know, that's why our guests are coming on today.
Indeed. So, tell us a little bit about who's joining us today, then, because I think it's a properly dream team to talk about what Earth Day is all about. So, can you introduce us a little bit while I bring them on?
Yeah, so we've got Hayley Evers-King, who is a marine scientist. She works on the oceans. Relatively recently got a PhD in Cape Town and is now working for EUMETSAT, which is a kind of a partner organization to the European Space Agency, sitting across the road in Darmstadt in Germany. They operate weather satellites, but they also operate Earth observation satellites. And our Sentinel satellites, which are specifically designed through the Copernicus program of the European Union, implemented by ESA, have a very strong relationship with EUMETSAT. So she's going to hopefully talk to us about the very complex dynamics in the oceans, which of course is most of the Earth. I mean, the little bit we're standing on is a fraction of the Earth, and the oceans have been soaking up enormous amounts of heat in recent years. Doesn't all go in the atmosphere. Most of it goes into the oceans from global warming. And the other person coming on is Mark Drinkwater, and he's a colleague of mine here at the European Space Agency. He's the head of science and mission, or mission and science in the Earth Observation Directorate of the European Space Agency. And he and his team of scientists are responsible for operating all of the satellites we have in tandem with EUMETSAT and other organizations, but also dreaming up the next ones with the scientific community. What are we going to do next? What do we need to study in order to understand the changing Earth even better? So Mark has come on and has clearly not quite figured out how Zoom works, because the button at the bottom which says, I have a green screen or not, and you don't have a green screen because you have some nice pictures from your kids there, Mark, but otherwise you're going to be the Aurora this evening and we're going to be jolly amused. So you figure that out, and so I just briefly introduced Hayley. So welcome, Hayley. First time we've actually met in person here virtually.
Welcome.
And I just introduced you as an ocean expert, so you should talk about what's in your Zoom background right there.
Yeah, so behind me is what we might call an ocean color image. This one in particular is from one of the satellites as part of the Copernicus program. It's a mission that's kind of collaboratively run between ourselves at EUMETSAT and ESA. And behind me, this is the Baltic Sea. And what you can see in amongst all these swirls of beautifulness by me, by the way, that's the north part of Sweden there. But the green swirls in the water are from a type of phytoplankton. These are tiny plant-like organisms that live in the ocean all over the world. And in certain places like this, at certain times, they bloom. And when they bloom to such huge amounts, we can see them really, really clearly from space, as in this picture. They are generally a good thing. They provide oxygen, some stuff we breathe. They're also the base of all the marine food web. But they can also be harmful. Cyanobacteria like these can be dangerous. They can be involved in various diseases. They can also cause irritations to people's lungs. So sometimes good, sometimes bad. This one actually in particular came after the massive heat wave we had last summer in Europe. So we think it's probable that they were kind of pushed into this bloom stage by the heat that we'd had, and that made the water column very, very stable, allowing them to grow to such a huge amount that we get these beautiful pictures. So yeah, that's cyanobacteria.
There's also the issue, if I'm right, and I'm going to play a partial expert, and I'm going to be embarrassed because you two know, obviously infinitely more about this. There is an issue, I think, though, also with fertilizers flowing into water. So providing them food, they can be a bad sign in that sense that we're polluting the environment. They can reflect that directly.
Yeah, they can cause eutrophication, as they call it. This green scum you get it in lakes. You also get it in the coastal zone. Forms these harmful algal blooms. It's the kind of general term for them, I guess. And they can be very bad. They can release these toxins, bad for our fishing industry, bad for aquaculture, dangerous to our health. And they can also they collapse when the bloom dies. We call it collapses. And this process whereby they decompose, it basically becomes like a giant compost heap. It smells absolutely terrible. I did my PhD field work in one of these areas, and it stinks to high heaven. It's absolutely disgusting. Looks beautiful at night because it all lights up with this bioluminescence, but it smells really terrible. And when it decomposes like that, it takes all the oxygen out of the water. And lots of the creatures that live along the bottom parts of the ocean in these shallow areas, they need oxygen to breathe like we do. And they're kind of forced out. So you get these huge lobster walkouts and things like that in certain areas where the oxygen gets removed. So it's quite a fascinating phenomena. If a little
I now have visions of crustaceans invading the earth because we're polluting the ocean, and giant crabs and lobsters taking over. I sometimes wonder in current government whether that's actually true, but we do get political here on Uplink occasionally.
That is certainly allowed.
So Mark, you're down there. You've decided that the home view is better than the aurora, but since you had the northern lights behind you there, give us a background on what it is.
I was being electrified. I was being electrified for a moment there by the aurora. Borealis wasn't fitting with my lack of green screen capability, so forgive me for that. Yeah, my background. Yeah, I'm responsible for fueling the design and the development of our Earth observation satellites. My division in particular is helping equip them with all of the right kinds of technology to do the kind of things that Hayley's interested in. And to that extent, we're trying to develop capabilities that will allow us to unlock formally unmeasurable parameters, or to observe things about the Earth and the Earth system that we couldn't formally access. And so we're developing and designing new instruments and new satellite capabilities that really give us a new perspective on the Earth. And I think the current range of measurements that we're making is already testament to the fact that we've achieved a great deal in the last number of years in delivering equipment in space, which is giving us perspective on Earth, which gives us a much deeper appreciation of how the Earth works, and also the impact that we're having on the environment.
Just as you speak about the environment, I suddenly hear an aeroplane go by. I tell you, that's the first one in about 2 weeks. But Mark is in the same town as me in the Netherlands, so you may hear the same one, but you've got your earphones on. Let me just follow up quickly before Alex jumps back in. So your personal scientific background concerns another area in Earth observation, which is very critical with respect to how we observe the Earth changing today. This thing called the cryosphere. So why don't you explain? Many people have not used that term necessarily before.
Yeah, the icy parts of Earth, of course, have been an obsession of mine since I was formerly a day-to-day researcher. I mean, now I pour my scientific experience into preparing a range of different kinds of satellite capability. But formerly, I was working on ice and climate, and what we can do with satellites to understand how the polar regions in particular are changing, and the impact not only of climate change on changes in the polar regions, but also the impact that the polar regions are having on the rest of the world. And the ice is a poster child for climate change in many ways, and it's illustrative of how dramatic the changes have become. And to that extent, we're day to day watching the impact of climate on the ice, which fringes the polar oceans and which covers the large continents, particularly Antarctica and Greenland. And there we see unprecedented changes in the satellite era, which are captured by our instrumentation and which illustrate the rate of change that warming of the climate is having, particularly in high latitudes. And it's the range of impacts that I'm most interested in. We're watching the impact that ice sheet melting has on sea level rise, for instance, and that has vast socioeconomic consequences around the world. We're also understanding how the change in ice sheets changes Earth's gravity, that it's in of itself influences how the envelope of water is redistributed around the globe, and that has consequences for where the imprint of sea level rise is going to be most sorely felt. It turns out that Greenland now is the largest contributor to sea level rise, apart from warming of the ocean, of course, which is about 50% of thermal expansion is 50% of the rise of the ocean. And the rest comes from the ice being poured into the ocean as a consequence of exchange of ice from the large ice sheets in the form of water into the ocean. So we're watching this with our satellites, and we're seeing the picture evolve. We're seeing the fringes of the ice sheets unravel as warming takes hold at the lower elevations around Greenland and Antarctica. So it's an obsession to watch these pictures. It can be quite disturbing at times, because we see how changes occurred in our recent past, and certainly in my lifetime as a scientist, short lifetime as a scientist, we've seen dramatic changes. So we're witnessing things as they unfold, and that gives us this impression of the pressing need to do a better job of managing the environment.
Yep.
It's interesting. I think I'll say Mark D. What you're saying, because it links back with one of the things that we're talking about at the very beginning before you joined, which is that it's the 50th anniversary of Earth Day. A concept that is so linked with pictures of the Earth from space. People for the first time perhaps seeing just how fragile our environment is, and just how small it looks against the backdrop of space. And so when Mark McCorcoran and I were talking about, what do we describe you guys as? We came up with the idea of planetary sentinels, almost like guardians, the people who are at the front line saying, we have something to worry about now. And something that you said really resonates is that you seem to be saying that it's startling, the change that you're seeing, not over decades or centuries, but in your own lifetime, within the span of your own career. Is that right?
I think that's had the greatest impact on me in my career, of course. If we reflect on what you just said, of course, Earth observation provides a unique perspective, of course. It allows us a privileged view to contemplate the magnificence, if you like, and the majesty of planet Earth. And only astronauts have been able to do that in the past. And now we're able to put in the public hands the same views day by day of the place of their greatest interest around the globe. And there's no better way to appreciate this majesty, if you like, than from the vantage point of space. And we have the privilege to be working in an area where we have the access and the tools to be able to deliver the public with this kind of perspective. And that's having an impact, and it's the images that we produce that also are the fuel for the kind of hope and optimism that we're generating information that can be used in a better way to manage the environment. And I think that's the message we would like to pass about the benefit of Earth observation and the role of the European Space Agency really in generating the source information by which we can better manage the environment.
So Hayley, you're obviously a bit younger than these grizzled marks over on the other side of the screen.
Very kind.
And I've got teenage kids. Well, actually, my daughter's now 20, and in fact, again, Mark and I live in the same place. We work in the same organization, and our daughters are friends from school days. And I hear a lot of discussion now in the younger generation about not so much looking backwards and sort of saying, you guys, you're just a bunch of wasters. You burned all the oil. You didn't care about it. I mean, we've known about climate change for 100 years, at least, right? The concept of it through John Tyndall and his measurements of how the greenhouse gases would work. But I'm curious, from your perspective, as somebody who's entered this field relatively recently, you know, how do you maintain that sense of optimism that Mark just referred to when, you know, if anything, things are just sort of speeding up at the moment, right? I mean, so we can't lose hope. We actually have to do something about it, not just bury our sorrows in drink, but you know, how do you see that future?
I mean, you're totally right. I mean, I think that it's very kind of tempting to fall into this kind of depression about what's happened to the planet. And I definitely have felt that throughout my career. You know, as you say, it's admittedly quite short, and it seems like maybe we're not winning some battles, but there have definitely been some we are winning towards, I think. And one major thing that has shown me kind of the capacity we have as people is something like the development of Earth observation. It really shows what we can do when we get together as a species across the planet and put our minds to something. We are incredibly technologically capable and creative when we want to be. So I think it's well within our capacity to address some of the issues that we have. And I mean, I think that's reflected in the decisions we've made to create programs such as Copernicus, you know, and all its predecessor instruments, you know, from Europe across the US, all around the world. It really is a testament to that kind of spirit of both human camaraderie and creativity and technological brilliance. So that really is what does give me hope, I think, every day. I mean, every time I look at these images and I can see what is going on, gives me confidence that we can get a handle on it and make things better.
How do you bring that to the public? Mark mentioned that, you know, the images appeal, they show people how the planet's changing, but I know, you know, you're active in outreach, in bringing that. I mean, you mentioned, you know, right behind you is Sweden, and of course the home of Greta Thunberg. And in some ways she's made as much of an impact on the public awareness of climate change in the last 18 months as everything that we've done. And I don't mean that that's a competition or anybody's fighting here, but it's also getting to people who are not actually geeky and not necessarily scientific and not clued in, but making very basic messages about how the world's changing. And for that, that's often a very local thing, right? You've got to bring it home to people where they live, what the changes are. So how do you see that perspective?
Well, we're fundamentally looking at our home when we look at these images. And I think it's very important for us, and I think especially on days like Earth Day, to remember that we are a part of this system. We are not separate from it. We affect it. It affects us. You know, we have to work harmoniously in this system together for our own lives as well. And for me, in terms of getting people to understand about our Earth and why it's important, but also, you know, why the data that we provide is useful for them, it is about bringing it down, like you say, to that local level, to things that actually matter in people's day-to-day lives. And for me, that again, with kind of why I'm doing what I'm doing with my career, this is a major driving factor. I like that our data can help people's lives. I like the idea of the planet staying beautiful and wonderful forever as well, but I want to make sure that people have jobs, and I want to make sure people's health isn't affected by things like, you know, these blooms that we were talking about. And that for me is a real power of Earth observation. And if you can show people that actually we provided these images, this decision happened and lives were saved, money was saved, more jobs were created, you know, that's something people can really tangibly understand beyond just the beauty, which is important in its own right as well, of course. But yeah, so I like to go for those kind of stories and to show people really what the relevance is.
I mean, please.
Sorry, Alex.
No, go ahead.
No, I jump in there to complement what you were saying, Hayley. But to put the data in the hands of the user is an extension of that as well. And one of the things that we've been trying to do is to develop apps to bring the data from an unmanageable format into practical, usable information. And to that extent, we're developing apps that go beyond the basic weather app. You can tell whether the air quality in your local area is sufficiently good to ride your bicycle to work, Mark, or you can go figure out whether the water quality off the coast here in the Netherlands is of suitable quality, no harmful algal blooms to go take a dip. And you know, the range of practical applications now that we're being able to put in the hands of the user by simple mobile phone technology is allowing us to get the user into the hands of the general public, which are the people who can most benefit really from use of the data at the end of the day. So that's one way we have to extend what we do to make sure that it's not only scientists and capable users who can turn the bits and bytes into value, but also the everyday public.
Yeah.
Yeah,
I mean,
I
just to
fully
pick up
agree.
on that, I mean, there's a sort of critical issue which everybody, needs to understand, is that when we talk about the Sentinels and the other, things in the Copernicus program paid for by European taxpayers, implemented by ESA, cooperated with EUMETSAT and so on, and yet all the data are free to air. They are no proprietary period. Anybody can get them. And that, as you say, is not just at the public level, let's say pretty pictures, but that companies and small enterprise can get those data and make something out of it. I mean, as you said, we've got apps which sit on my phone, which have been made by people which are constantly relaying the distilled version of that data. And this is a critical element of this whole program, that those data are free. Now, that actually, of course, means incumbent on ESA and EUMETSAT to have huge computer systems with a huge amount of bandwidth to make that possible. So I'm just using it as a jumping off point, because, of course, you're here in the Netherlands. Hayley's there in Germany, and the other place which is important to us in Earth observation is in Italy. So maybe you should say a little bit about what goes on there in Esrin.
Esrin is based in Frascati, just outside Rome, and that's our sister organization to ESTEC, which is really the technical heart, if you like, of the development of the satellites. Esrin is responsible for managing some of the spacecraft in orbit, as well as a data delivery port of call to many of our users, particularly for the scientific data. Of course, Hayley can tell you more about the way in which EUMETSAT complement what we do in the operational domain. But Esrin is delivering our Earth Explorer satellite data, as well as some data products from the Sentinels, the Copernicus missions. And of course, the operational meteorological data, which feeds the weather models in countries around Europe and around the world, is being ported also through EUMETSAT's data delivery mechanisms. But the idea is to get the data out 24/7 and to ensure that it gets into the hands of the users in a timely way, particularly those that are wanting to base forecasts on the timely use of the data, or wish to turn out products and services for the benefit of a whole range of services, everything from food productivity, water management, as I mentioned before, water quality, ice charting for ships around the Arctic, and security, safety applications, disaster relief response, and many other things of practical value to people around the world. So it's not just a European benefit in that sense. It stretches globally, and of course, as you said, it's free to air and free to use.
And of course, I mean, it's so important, to ensure that data gets out there. But I also wonder, just in terms of Earth Day, and in the context of this current pandemic, I mean, many people have been startled by how quickly the Earth seems either to be changing or seemingly recovering and so on. Have you been surprised by some of the images that have surfaced just in the last few weeks and months? Because certainly, to my eyes, I did not expect that things could change that quickly. Hayley?
Yeah, I think you're right. I mean, there's been a lot of images that have come out and which shown really the power of what we can do to look, today versus last year versus many years, which is, an important kind of background to think about here. We have very high frequency variability that happens day to day. We have things that happen over much longer time periods. Satellite data is amazing for us being able to tease apart those things. But yeah, I mean, some of it is very, very clearly linked. When we've controlled for other variables and seen changes in things like the air quality, the water quality in certain places. It's actually something, I mean, for me, I think this is going to be an incredibly rich vein of information for us to kind of work through in the coming years to learn so much more about the processes of how Earth might respond to different forms of, say, mitigation we put in for climate change. I mean, but this is really an experiment. It's an incredibly sad one that this is the situation we're in. But I think we will learn a huge amount from it. So yeah, even though I'm used to seeing the images, I've been surprised by just how many different things we can see.
I think air quality is one of the things which has captured the attention, particularly because of the ramp down industrial activity sequentially in different places around the globe. And I think one of the most evident patterns has been the reduction in various trace gases, which are pollutants caused by combustion. And the lack of vehicular use and aircraft and ramp down in industrial activity has meant that there's significantly less emissions of things like nitrogen dioxide, the brown stuff that floats around in the atmosphere above cities. And this is typical byproduct of combustion or industrial activity. And what we've seen in forecasts on the news now are information produced by our satellites on a daily basis globally that illustrate how there's been a dramatic reduction in some of this type of air pollution, particularly in around city and urban and industrialized regions around the globe. And I think there's been a very visible and dramatic change in the air quality. However, the flip side of that, which I find most concerning in these COVID times, is the fact that it's those very regions where the people are most susceptible to respiratory problems. It's areas where they're suffering from poor air quality for a significant portion of the year that the people are most hit by COVID. And there's a certain irony and twist in that message, because those places that could benefit better from mitigation of the poor air quality are the places that are likely to suffer the most throughout this period. So we can certainly learn from this whole experience with COVID influencing the extent to which we see the air quality change. And this is a lesson, as Hayley said, about how future mitigation measures can be implemented to the benefit of the general population.
So, a couple of things there for me. One very general. Again, here we are in the Netherlands, and you're just a kilometer or two away from me. And actually, even though we have the North Sea and we have the winds that blow here, we're in one of those polluted regions on the planet when it comes to nitrogen dioxide. And that's partly due to the very high density of people here, but also the oil refinery down in Rotterdam and big industry down in Antwerp and so on. And frankly, I've lived here 10 years now. I've never seen it like this. Now, and it comes back to what Hayley was saying, right? There is this short-term issue we call weather, and there is this long-term issue that we call climate. And maybe we'll come to that in a little bit, because that confusion still, gets people. It's like, oh, look, it's snowing today and it shouldn't be snowing. That's weather. Climate is something else. But I had another question, a bit more technical, maybe. Given that we've turned, often when we do experiments in science, we have many conflating variables, things which are all going on at once. And sometimes some are really dominant, and it's hard to tease out the smaller variables, which might be really important, but we can't see them. And sometimes, for example, we do experiments by going to the International Space Station. We turn off gravity for things which are actually meant for Earth, making pharmaceuticals or the oil refining and things. We learn by going to space by turning off one of the big variables, and then we apply it on the Earth. My question there is, by turning off things like nitrous oxide and other pollutants, are we able to do experiments now that wouldn't have been possible otherwise on other traces like methane and so on? I mean, again, I'm out of my domain here, but does this actually open up not just tracing how those things influence, but other things which may be very important buried in the data sometimes?
That's a good question. I'm not an atmospheric composition specialist, and the unfortunate thing is weather doesn't comply always with trying to recover trace gases from the atmosphere, nor does recovery of some of the particularly important greenhouse gases become any easier when you have loading of things like aerosols from combustion. So it's when the weather's favorable that we're able to do best, ironically, in looking at climate trends in things like methane and other important trace gases. But I haven't spent enough time thinking about how we might benefit from this interval for some of those more difficult trace gases, to tease them out of the record. I'm aware that right now we're profiting in Europe from unbelievable weather, which is more to do probably with climate change than anything else, because of the high pressure that's been sitting over Europe has afforded us unbelievable clear blue skies now for a matter of weeks, and that's a consequence of the jet stream, and perhaps even the temperature distribution over the northern hemisphere, which is helped and aided and abetted perhaps by a reduction in the temperature gradient between the polar regions and the mid-latitudes. And when we talk about polar changes, one of the consequences of warming of the Arctic is that we reduce the temperature gradient, and the jet stream meandering allows these pressure features to reside for some long periods of time, and we found ourselves in a high pressure situation in Europe that's allowing us to look at the trace gases and how they change without the perturbations that would ordinarily be caused by cloud cover. So we are in a fortunate situation from the standpoint of monitoring what's going on from the standpoint of some of these gases, and how COVID and the lockdown is having an impact. It's giving us a very useful diagnostic data set, as Hayley was saying, to allow us to study how policy measures in the future with things like carbon dioxide or methane can beneficially impact the quality of air in Europe. And I think that's going to be one of the benefits of this right now.
I'm actually really interested to look some more at some of my favorite data, so ocean color, the stuff behind me. One of the problems we have with this data, one of the challenges when we're using it, is we have to remove the atmosphere to get to what's in the sea. If it's cloud, we can't compensate for that. It means we can't see the sea, which is a shame, but we've had this beautiful weather, as you say, so we've got a lot of clear overpasses from the satellites at the moment. One of the other factors in the atmospheric correction process that we have to account for is things like aerosols. And I imagine a lot of coastal places now, we're going to have a very different atmosphere to what we've been used to correcting. So it'll be interesting to see actually how the data looks now, maybe compared to other times, and whether we're getting clearer, more accurate data as a result of this.
Yeah. I mean, for me, I remember not just this year, we've had this pretty, well, I'm very deliberately not using words like beautiful and incredible and lovely, because, you know, they should scare the crap out of us, frankly. I remember last year in February here in the Netherlands, it rose to 25 degrees on a couple of days. And there's this weird asymmetry at mid latitudes, you know, where we live, because, you know, typically it would be rainy at this time of the year. There'd be a mix of weather. There'd be wind. There'd be maybe, remember a few years ago, we had the so-called beast from the east, this weather that came in from Russia, and it was below freezing in May. I mean, I cycled through this thing. I just could not believe it was going to keep going. But there's the symmetry. When the weather turns good in the winter time, we think it's lovely. We don't actually think that's a negative thing. We don't look at that and say, actually, this is a bad thing that it's like this at this time of the year. And in the summer, it typically doesn't get too hot, although last summer was an exception, where we get utterly boiled and say, well, you know, that's the other side. But if you live at lower latitudes, you know, you're really seeing the other end of the distribution, right? Temperatures rising in the Gulf states above 50 degrees at crazy times of the year. So again, there's that sort of perception thing that humans put on that. They put a kind of a shiny gloss on good weather in the winter, when they should actually be complaining bitterly about it. I mean, I have to say, you know, okay, we've got other things to think about at the moment, but it's kind of scary that it's this temperature, this time of year. Yeah,
it definitely is. I mean, it's been very, very nice here. And I mean, I moved to Germany last summer, and it was the hottest temperature I've ever experienced in my life, anywhere in the planet. 42 degrees, I think we hit in Darmstadt. And it just felt so wrong for it to be that hot to me. But you're right. I mean, the perspective is the same right now. It possibly shouldn't be this hot. And if you're closer to, you know, sort of certain tipping points or slightly stretched anyway, I mean, this can end in quite severe consequences. I mean, I used to live in Cape Town, and as you probably heard, I mean, they had this very severe drought that lasted for, you know, had effects kind of rolling over a couple of years, to a point where this major city nearly ran out of water. And you know, I was in the UK at the time, was watching that from a distance by satellite, just seeing the dams drop in level and the fires, get worse in the area and everything drying out. And yeah, it really brings home the potential impacts when you see it.
One of the benefits of the data that we have, Mark, is that we can track the impact of events like this on the drought situation, on soil moisture. So we're measuring soil moisture with our SMOS satellite, which is giving a view and a picture of the imprint of these kind of events in terms of deficit of water or surfeit of water, and where that's related to these patterns. At the same time, I looked in Greenland today, the way the jet streams bifurcated and shot up over Greenland and around this high pressure sitting over Europe, that's having a beneficial effect in Greenland. It's dumping snow. It's bringing warm, moist air to the southeast of Greenland right now, and it's been dumping snow on the southeast of Greenland, which a benefit from the standpoint of snow accumulation. So you can see with the satellite data that we have access to, we can see the imprint of these patterns, and we can track them from day to day, which is the wonderful thing about the access to the data that we have.
Let me just, sorry, Alex, just one last thing, because, often people think we just go up in space and we take photographs, right? And it's all done just by looking at images. But you mentioned something there, how do you measure soil moisture from space, right? I mean, I could go and stick my hand in a bucket of dirt and say, oh, that's a bit, it's a bit runny, or that's not. But you're hundreds of kilometers up in space. How on earth do we measure soil moisture from space?
Yes, microwave emission is influenced. Our satellites measure thermally regulated microwave emission. It's emission from the surface in the microwave part of the spectrum.
So like the microwave I have in my house to nuke my food.
It's the same wavelength as your mobile phone. It's L-band. It's wavelengths that are about 20 centimeters long. And the satellite listens to emissions from the Earth's surface that are governed by a combination of the temperature and conductivity. And there's a relationship between the amount of water in soil and how conductive it is, and that generates thermally generated microwave emission, which can be measured by the satellite. And we can measure the amount of water in soil from 0% to a few percent quite accurately. And what this allows us to look at is the amount of water in the top of the soil, which has an influence on the growth of vegetation and which has benefits obviously for agricultural uses amongst other things. So soil moisture is one of the new developments in space capability over the last few decades, and it's something that's prized information, particularly for services for agriculture and things like that. I don't know, Hayley's probably got other examples of development of new products. I mean, our satellite that measures soil moisture also measures ocean salinity, which is fundamental to how the ocean stores carbon, for instance. So maybe you want to say something about that, Hayley, because that's another fantastic new application of the data.
That's a really interesting one, and actually it speaks to, I mean, the salinity is one part of the carbon story, like you say, but this idea of how much carbon the ocean takes up is really a kind of triumph of using multiple different satellites together. So, I mean, we have information that's coming from the salinity measurements, but we can also measure other parts like the visible behind me, which can tell you about what's in the particulate part of the carbon cycle. And you can estimate kind of the whole carbon cycle system within the oceans to figure out what's going on. And this has particular relevance for this issue of ocean acidification, which you mentioned earlier, as well as the carbon in the atmosphere causing this warming effect, which is causing all these complex changes in our climate. The absorption of carbon into the ocean also changes its pH, which effectively kind of makes things say dissolve, but it's not really dissolving. It changes the pH. It makes it more difficult for creatures that live there to form their shells or to make them as resilient. Things like coral reefs, but also these little creatures like phytoplankton, like the ones behind me, they also have a role, different species of them in this cycle. So we can use these different measurements together to kind of add further value down and figure out more about the ocean than we can directly observe. It's a really exciting time, really, to be able to do that kind of thing.
Indeed. I mean, it's an incredibly exciting time, and yet, you know, and I can say this not as a space scientist or, you know, a planetary sentinel, but simply as an enthusiast, as a concerned inhabitant of Earth. You know, a lot of this information is completely startling, and yet I am appalled that so much of it is politicized, ignored, misinterpreted, and so on. I mean, do you, at a personal level, ever feel frustrated to see a lot of this incredibly important information, these findings, being overlooked because we truly never known as much about ourselves as we do right now?
It's a bit paradoxical because there are countries that are embracing the use of the kinds of data that we're producing now, and there are politicians who are putting in motion policy endeavors that are based on science and the kind of data that we're generating. So I can't say it's definitely applicable everywhere in the world, that kind of opinion. We see certain countries in the world, of course, where politicians prefer to turn a blind eye to the science and to the evidence that's being shown in the data. And I would certainly subscribe to what you said about being frustrated sometimes about the short-term view of politicians that blinds them to the evidence. I think they choose more often than not to subscribe to showing the evidence because it's not in a way supporting their views. So yeah, it's a frustration for me, but of course in Europe we're thankful that at least with our work closely with the European Union, we've built a system that's providing tangible evidence day to day, and it's undeniable in a way, the value of this information for making informed political decisions. And so we'd certainly like to influence those other countries around the world who choose another route right now, and we hope that we can evangelize in a way and show the benefit for management of Earth.
I agree. I mean, it is frustrating. You see, if you've seen these things for as long as some of us have, it's hard not to feel like the pace of change is, you know, unbelievably slow and not enough. And you think, we know this, why can we not change it? But we do have these tools now in order to also help suggest what the changes should be. And I think that's, you know, a power that we can bring more to bear now, especially with the fact that these systems that we've got now are so operationally kind of focused. You know, they're there to provide information daily that can actually help. So, you know, we can use this to support the growth of businesses that are more, you know, to make things more efficient, so that we're not, you know, trading off this environment versus people or economy. We can try and bring some great examples of that in the Earth observation world. I mean, examples where we've helped optimize shipping routes, for example. So shipping can still go ahead and it actually saves them fuel while cutting carbon emissions. You know, everybody wins in this situation. The same with some fantastic examples I saw recently of using, I think it was Sentinel 2, but possibly also some of the soil moisture stuff to look at fertilizer spreading and where you should best kind of farm optimally. Again, saving fertilizer from, I mean, it's a cost reduction for a farmer, but also less going into our rivers and into our oceans and causing eutrophication. So again, everybody wins. And I think we have, with all this information, the power to do much more of that, to, you know, bring people on side as well, to make those choices less difficult for them.
Yeah. It seems to me it's something I reflect a lot on. I mean, you know, in the exploration and the space science side, you know, the Earth observation program is utterly fundamental, because it's, you know, we could, my colleagues won't like me saying this, we could go to Mercury in another 20 years time, you know, it'd still be there, but, you know, the climate now, and I found myself frustrated by, but there's also, you know, the other level beyond that. I mean, Mark quite rightly said that, you know, some politicians act in a short-term way, but in the end, they have to get elected. And one of the things which preoccupies me a lot is why it is that we have gone into a world where we have more information, we have better science communication, we have politicians who are engaged and many of them educated in science, maybe not enough, but some. And yet at the same time, society is bifurcating into people who want to use science and understand it, engage with it, and others who are beginning to deny it. And I wonder whether that, beyond the politicians who are playing with that, whether there's actually a kind of people are worried in a sense. Maybe it's that, people are scared, and rather than being able to engage with it, they are denying it because they can't cope with the fact that the world is going to change. And I think it's what you said, Hayley, is how do we provide clear leverage that people can say, I can make something out of this. I don't have to give up everything today. I can work with this, but learn the lessons and then progress. So I think, that message is something, sometimes it's hard, you don't want to give up and throw it all away, but we can't give up, right? I mean, we've got to do what we're doing. Again, Mark and I have kids. I mean, the younger people, they've got to look for the future here. And giving up is not the answer.
I think building a better environment has to be the mantra, and it's something that we're actively trying to engage and contribute to. If we think about some of the efforts that have led to really positive moves, there are examples of use of space data for establishing protocols that have led to reduction in chlorofluorocarbons, for instance. The early measurements of the ozone hole from satellite led to the Montreal Protocol. Governments of the world came together to establish protocols to limit emissions of harmful substances, ozone-harming substances, and that's led to positive developments and to some degree the recovery in the ozone hole as was predicted at the time. Now, what we need is similar moves, obviously, for reduction of greenhouse gases. And one of the things that we're trying to do in Europe now within Copernicus is develop a CO2 monitoring system with our EUMETSAT colleagues, together with the European Centre for Medium Range Weather Forecasting and the European Commission. We're teaming up with the Japanese, the US, and we've got a lot of other players who want to get involved, like the Chinese, so that we have a global monitoring system that will allow us the tools to monitor how the pledges that are made by countries in the Paris Agreement are being met, or better still, how the policy moves are influencing reduction in emissions and having a beneficial impact on CO2 emissions worldwide. And so by putting in motion these kind of systems, I think we'll have a much better capability to manage the way in which politicians react, and to put the information at the fingertips of the public so that they can hold them accountable and vote in a manner that's consistent with who's going to give them the better living standard and environmental conditions in the future.
Yeah.
Well, I think that's an incredibly interesting point there, and I've got to say, I mean, this time is completely flown. Mark, I'm sorry. Did you have something you wanted to say there?
No. I was actually looking at you. You may have questions which have come in on the stream at this point. This is typically when we get to questions.
Indeed, and I guess first off, hello and thanks to everyone who's actually joined us on Uplink. We have some great questions, some great comments and things, and it's wonderful just how well this dovetails with what you're just saying, Mark D, about Christina Vrincino has a question about how can scientists best communicate Earth observation results, because so much is communicated through journals, through conferences, but what can we do to make it accessible to everyone? You talked about apps, before. Is that the solution? I mean, what more can space science do, I think, to make this commonplace?
Well, the weather forecast is a good example today. It's common for the everyday public to use weather, from which the source is largely satellite data today, as well as on ground measurements. But weather's in the mind's eye of the public before they ride the bike, before they cycle to work or go on holiday. They look at the forecast, be it short term or long term. We'd like to make sure that we bring the information products to the public in a similar way. And for the first time, the last weeks, we've been seeing things like chemical forecasts or air quality forecasts on the news around the world. There's been a global uptake of this kind of information because of the stark evidence of reduction of air pollutants, for instance, during COVID crisis. So I think that there's ways in which we can bring the information to the general public through the news media, which haven't been investigated so far. And I think they're catching on to the value of other types of information than pure weather. And maybe Hayley's got similar such examples.
Yeah. Where I previously worked, we were involved in this kind of smart sound. I lived in Plymouth. Plymouth Sound is the kind of bay where the city is. They had this smart sound concept, which was about getting information about the sea environment, which the city is intimately connected to, thanks to its naval history and maritime industries, into kind of the everyday public. So they had these things all around the city, and they're planning more and more to show people what that information can actually tell them about where they live directly. So it's about bringing it down to the individual. But I think we can also look at ways of bringing the data to life in different forms of media. I mean, social media is great. I mean, the sharing of these images on Twitter by, even just a sort of relatively amateur members of the public who just find it interesting is an amazing thing they do. But we can also get it into things like, documentaries. I think BBC did a fantastic example of this a while ago, this Earth from Space. I was involved a while ago as well in 2 different projects which used poetry and a full orchestra all around Earth observation data, which sounds weird. You think, how do you connect those? But I spent some time working with a poet who wrote a piece about ocean color data. And I worked with a composer who did this whole interactive piece about, it was about climate change. And she used these long time periods of satellite data to feed into an electronic music track that was kind of in the background. You had these bone shock headphones, they were called. They kind of sit on the side of your cheeks. And you listened to that as you walked around the orchestra playing with their, myriad different instruments. And it really brought the data to life in a very different way. And it helps people to understand really then what it meant. I mean, the climate change piece, for example, was obviously quite dramatic, but there was this very slow kind of build, which we know is kind of, it's not necessarily an events kind of very quick thing. Climate change is something that comes and goes in events, but also has this very long time period that it's acting over. So there are different communication media that we can use, I think, to our advantage.
Great. I'm sorry, go ahead.
Yeah, I was just going to pick up on that. We were going to talk about this a little bit earlier on, perhaps, but as you know, today it was Earth Day, so we did a couple of things from the ESA side as well to communicate that. Lots of interesting information can be put out there in different ways for kids, for adults, but sometimes it can be something as simple as a piece of music and some words over the top. So today we were contacted by an old friend of ours, Vangelis, a famous composer, wrote the soundtrack for Chariots of Fire and Blade Runner. At least of the older generation, we know him very well, his music. And we worked with him several times over the past few years, partly through the astronauts. Andrei Kaupers talked to him from the space station, then he did some Rosetta. But in 2018, he worked with the family of Stephen Hawking just after his death there. And a piece of music was composed which combined Vangelis's his music and words by Stephen Hawking about the state of the planet and about how it is that, for all that he was looking out into space in his career, virtually speaking, it was the planet Earth which most preoccupied him and the state of it. It was played at the funeral in 2018, and Vangelis approached us last week and asked, can we do something at this point in this really extraordinary time to talk about, hope and solidarity, and a sense that, we can get through what we're in today. And he didn't just mean the coronavirus crisis, but also climate change. So we worked with him, with the Hawking family, with Lucy Hawking, Stephen's daughter, and with our video editors in the last few days to bring together a video which has images like the one I have in the background here, showing the Earth in various ways from the Earth observation satellites, also looking out into space, looking at the Earth on the ground, and put that out earlier on. And I'm really impressed by just how that's captured the imagination of many people. It's one piece, it's one small thing that we can do, but as Hayley said, you've got to be pushing on all of these things at the same time, because one thing that we've experienced in the past with things in ESA is there's a cumulative effect. Things add up. If you just do one thing and then let it go, and then do another thing another week and let it go, you don't catch imagination enough. You can't build on it. So we also have been working with an artist today, one of our own Space Rocks alumni who was on Uplink recently, Anna Phoebe, violinist, She was on a couple of weeks ago now, and she released some work which is inspired by climate change, a piece called No Planet B, which she played at the Space Rocks event last year, and she's going to release it soon. She put a short piece out today, and it's got Earth observation imagery in there. So again, you never know how these things are going to work, but you've got to make those contacts. You've got to come down to the things that appeal to people. I mean, this is what we do in Space Rocks, but I just suddenly realized have we ever done anything with sport? Is it about time we did, Earth observation football of some kind, or I've no idea, right? But you're kind of motivated by the fact that sport is a hugely important and popular thing to many people. And so there are many things which people engage with, and we have to find ways of engaging with them in their world, not drawing them always into our world, because they may not be interested in soil moisture or anything else, but they all live on the same planet as us, and they also pay for what we do. So it's incumbent that we go to them, we go to their communities and see what it is they want. And maybe it's a piece of music, maybe it's a football match between Mark and and Hayley's team, EUMETSAT versus I don't know.
I think so to come back to the question, we do have to do a better job to bring the message home, and it's certainly something that we'll endeavor to work on, to find the right tools and the right way of communicating, be it a combination of music and images, or apps, or however best to put the information in the hands of the public, and that's our obligation.
Fantastic. We have another great question from Jeff, who is actually asking us just, do you feel like you've experienced something that's more commonly associated with astronauts, this overview effect, the idea of the Earth being a fragile thing? Have you felt not just, I suppose, wonder, at what you've observed, but also this kind of like this profound change in the way that you see the Earth as well?
Absolutely. I think for me, I mean, I came into this field because I was interested in the environment as a young kid, keen on like recycling and saving the whales and all these kind of things. But it was when I was studying and I saw these sorts of images that made me really realize that is what I need to do. That is the most important perspective we can have. And it really does every day still fill me with wonder. That sounds kind of a bit sort of trite to say it, but it's very, very true.
I resonated with the film and the message today in the Vangelis and Stephen Hawking piece, actually. And this capture, some of those words capture how I feel to a certain extent. Space gives a perspective on humanity itself. We see the divisions, we see unity and not the divisions. One planet, one human race. This global view, it brings feelings of unity and global kinship, or awareness, certainly, about the globe. And it brings sensitivity. And I think we need all of those things on Earth Day.
Yeah.
The collaborative nature of the industry also is the same way. I think that we, to do these kind of things, we have to work together. I mean, we work together across Europe, for example, across various organizations in Europe, but we also work with our colleagues all over the rest of the world, USA, Japan, we've just mentioned a few during this discussion. And I think, space in every form requires that. And so does our planet.
I was just going to pick Mark up on there, and because you have a special connection to Stephen Hawking that you told me yesterday. So I think this is the moment, Mark. Yeah. This is where it has to come out. So.
No, I had a former girlfriend who used to wheel Stephen around when I was at Cambridge, and of course I had the pleasure to meet him. And I thought his words today were inspirational. And I think the way that you've blended the music and his soundbite is very pertinent for today, and I appreciate the work that went into it, actually.
Yeah, well, thank your friends in Esrin. So that's why I mentioned earlier on, Marco Civita there, and Carl Walker, who's here at ESTEC. But lots of people brought it together. So yeah, but in the end, the names don't matter so much as the message, right? And I think there's a real resonance there, as you say. And we don't, maybe we lack I don't know, do we lack a kind of an Earth poet? Carl Sagan, perhaps, for space science was a lot of people talk about his work on Cosmos and things like that. We talk about Carl Sagan a lot on Uplink, so it's kind of inevitable to get around to it. But of course, he spoke about the planet as well. He spoke about nuclear winter. He spoke about the change in the climate. Is David Attenborough that person today, at least for the English-speaking people in the world? Certainly, he's outspoken. As we've just said. Yeah, do we need a poet? But do we also, where do we become political as well? Because, you know, Mark, I mean, and I'm sure it's true for EUMETSAT as well, that it's kind of prescribed that we should not be political, that we should put the data out there. We should show the world what's happening, but we as an organization shouldn't be political about it. And I you know, I'll be honest, right? I struggle with that because I'm a citizen as well. I'm not just a person in an organization where I know these data come from. I feel that I want to be political in that individual level. So how do you see that? I mean, how do you see politicization within an international organization like ours?
Yeah, that's it's a difficult one to answer because we've turned to social media to perhaps be more expressive about these things in a way that's somewhat dissociated from our day-to-day job, and I see that as a way of venting on these kind of issues. But of course, we shouldn't be judgmental in terms of the interpretation of our data, and I say that for the simple reason that we don't have a political agenda. We have only one thing in mind, and that's to use our data to make the world a better place, and that's an ideal that I subscribe to in an apolitical way. And so, okay, we can express our frustrations about the politics going on around the world and how it's not necessarily helping. But today, I think we should project a positive message about how these data can be used in a positive way to manage life on Earth. And you know, if Carl Sagan could express that, or if we had a space poet laureate or whatever it is, I'm sure they would find more eloquent words and a way of expressing things.
You see, Mark, I think we actually have a job there. I think we're going to have to go find a space poet.
Space Rocks poet laureate.
Indeed, I'm totally up for that. So the time is absolutely flying. So I think we're going to end on I think a great question, especially when we're celebrating a milestone like the 50th anniversary of Earth Day, which comes from AMT, which is what's in the pipeline for Earth observation. There are a lot of satellites that are due to go up soon. What can we expect in the coming months or years from Earth observation? What can we look forward to?
So from my side, I'm very excited to be involved in kind of the first, because I've been doing my new job now at EUMETSAT for about 6 months. This is the first mission I've been involved in the prep for. We will have Sentinel 6, Michael Frulich, being launched later this year. So this is a altimeter. So it's going to be another one that adds to this very crucial observatory for things like sea level rise and for sea ice measurements and various other things. So we're currently preparing for that mission to be launched. It builds upon a lot of the technologies that came through Cryosat and Sentinel 3. So it's an exciting kind of addition to those that heritage of sensors. And it will be this crucial role in this continued archive that we so badly need at the moment. So I'm very excited for that one, but we've got lots of other things to look forward to in the coming years too. I'm sure Mark might say a bit more about how the development's going on ESA for those. Yeah,
Sentinel 6 is one of a series of Sentinels that's watching over Earth and helping take the pulse of the planet. We've got 2 other Sentinels coming in the next few years, Sentinel 4 and 5. These are a complementary pair of satellites that'll help us monitor global atmospheric composition, chemicals and aerosols and pollutants and things like that around the globe. One of them will stare at Europe, so it's a geostationary satellite. From afar, it'll make regular routine measurements to give us an unprecedented view of how gases in the atmosphere are changing over the course of the day and weeks and years. And at the same time, we'll have another one that's polar orbiting that's complementing it, giving us a global view of how those patterns are changing. So those are 2 to look out for. At the same time, we're preparing a suite of 6 new Sentinels for the European Commission for this wonderful Copernicus program that we're have as a joint endeavor now with EUMETSAT, EC, and other organizations. And those Sentinels will measure a range of things. We'll have a wonderful mission to measure carbon dioxide in the atmosphere. This will be part of this CO2 monitoring system that I talked about, which is going to help us with the Paris Agreement. We got ones that's going to measure the ice thickness at the poles and the ice cover at the poles. We've got one that's going to measure surface temperature. It'll be used in agriculture for monitoring evapotranspiration and for use in irrigation advice, and for agriculture, that's water management is very important. And then we've got a couple of other missions that'll measure things like biodiversity and changes in croplands and vegetation around the world, as well as monitoring mineralized zones and a variety of other things like water quality. And then we'll have a last one that'll help us with operational maritime applications for security. It'll help us with ship routing for wave conditions. It'll help us with where there's ice in the ocean to better aid navigation in icy waters like the Baltic or the Arctic. So we have a fantastic slate of things in the pipe, and we really hope that we can get not only the public and taxpayer support for what we're doing in endeavors like Copernicus, but we hope that they can, the voters can ensure that we have the support to fly this Copernicus system for the indefinite future. It's brought a step change in our understanding of Earth, and it's bringing us wonderful information about the planet 24/7.
Very good.
Just one thing from my side. I mean, I think this is, Mark and Hayley have said it, but just to emphasize, Europe is a leader in this. Europe is leading the world in monitoring the environment, not just for Europe, but for everybody else. I think that's something we should be very proud of as Europeans. And everything else said, you've got 3 Brits on the line here. We're all Europeans still, right? We work for European organizations, and so we're Europeans. But just one last thing, I always like the idea of blowing the mind of some of the people who are listening online. I just struck by your comment there about Hayley, Sentinel-6, measuring an altimeter from space. Right, I can get a ruler, I can go and measure how big things are, but between the pair of you, just give us a sense for, what can we actually do from space, from a satellite orbiting hundreds of kilometers? How accurately, how can I measure sea level rise, right? I mean, I can't be going up that much.
Well, the reality is we can measure sea level rise to accuracy of, millimeters, and it's down to fantastic precision technology from industrial concerns in Europe, and that they can measure, they can time a pulse from 700 or to 1,000 kilometers altitude above the Earth's surface, and they can time it so accurately that you can measure the height and the height variability very precisely. And we're relying on these tools more and more today, and the altimeter has become one of our arsenal of fantastic measurement capability.
Yeah, no, the altimeters really are quite a spectacular feat of accuracy when you understand, like how Mark spoke about it earlier, the various different things that can affect the sea level. I mean, the sea level is not a flat thing we measure anyway, right? I mean, even if you look out, you see waves, but we know that these huge ocean currents also cause like doming on massive scales, in the centers of the ocean gyres where you've got dynamic currents and all this, and the altimeters measure this too. So separating out that small part that is related to the sea level rise as opposed to the tide or changes in actually even the Earth's our sort of crust and how the continents and things are moving up and down. It is astounding that we can do that, but we can, and it's a very, very impressive system for that. So looking forward to Sentinel-6 for that.
Yeah, watch this space.
We'll have to invite you back to do a kind of a blackboard demonstration of exactly how, without dropping a plumb line from space, you can measure it. Just blows my mind. It's amazing technology. It's amazing.
Amazing technology, and tremendously inspiring and informative conversation as well. Mark and Hayley, can I say what an absolute pleasure it was to chat with you on behalf of everyone at Space Rocks and
Alex,
today for the live stream.
Thank you.
Really great to have you on. And before we go,
the last tradition that we have to do. So in Space Rocks, we have we have Space Rock's hand signal. So, and Alex hasn't been practicing because his thumb's in the wrong place.
The thumbs out.
So
And then,
space is the Vulcan
Yeah.
salute, and rocks is rock music. So Space Rocks, thank you very much.
Space Rocks.
We'll talk to you soon. All right. Thank you very much. All right.
Again.
Bye now.
Great. Thank
Bye-bye.
you. Bye-bye.